Hi, Mr. Richards here, and today's lesson is on parallel and perpendicular lines. Our first key concept is parallel lines. So if I start off with the line going in this direction, and I continue with another line going off in this direction, these lines are considered parallel because they have the same slope. They'll never touch. So parallel lines have same slope. Of course, it gets a little bit more complicated than just having the same slope and not touching. To write an equation of a line that is parallel to a given line, we're going to do two things. The first thing is that we're going to find the slope of the given line. The second thing you're going to do is substitute a provided point and the slope you calculated or found into point-slope form. In example 1a, write an equation in slope-intercept form for the line that passes through 4, -2 and is parallel to the graph of y equals 1/2 x minus 7. Step 1, the slope of the line with the equation y equals 1/2 x minus 7 is, well, this is in slope-intercept form. And our m is 1/2, so the slope is going to simply be 1/2. So the line parallel to y equals 1/2 x minus 7 has the same slope, which is just 1/2. So to find the equation in slope-intercept form here, we need to first write it in point-slope form. We have our slope of 1/2, our point for -2, and we'll put it into the point-slope form. So we make our substitutions in the -2 for y1, the 1/2 for m, and the 4 for our x. We'll now simplify this. We have y minus a -2 is y plus 2 equals, we need to distribute the 1/2. So we're going to have 1/2 x minus 2. And now to get this into slope-intercept form, we need the y alone, so we'll move this plus 2 by subtracting 2 from both sides. We're left with y equals 1/2 x minus 4. Example 1b is very similar. Write an equation in slope-intercept form for the line that passes through 2, 3 and is parallel to the graph of y equals 1/2 x minus 1. So the slope of the line with the equation y equals 1/2 x minus 1, looking for this m term here, it's the 1/2. So the line parallel to y equals 1/2 x minus 1 has the same slope, just 1/2. So we'll find the equation in slope-intercept form, of course, by starting off in point-slope form. We have our slope of 1/2, our point 2, 3. We're going to make our substitutions in. We have our y minus 3 equals our slope of 1/2 multiplied in parentheses the x minus 2. Now we can distribute this 1/2, so we're left with y minus 3 equals 1/2 x. 1/2 times the -2 or minus 2 is minus 1. Now, to finish, get your y alone by adding 3 to both sides. And you're left with our answer, y equals 1/2 x plus 2. Our next key concept is that of perpendicular lines. Perpendicular lines are lines that intersect at right angles. So here we have two lines that happen to intersect, they cross, and they're meeting at a right angle, so these are perpendicular lines. Now the slopes of non-vertical perpendicular lines are opposite reciprocals. Now, opposite reciprocals, if one of the slopes was 3/4, the reciprocal to that is simply 4/3, but to be opposite reciprocals, it's going to be a -4/3. So 3/4, that's one slope. The opposite reciprocal of that is -4/3. If you had a slope of, say, 2, the opposite reciprocal of that, well, the reciprocal of 2 is 1/2. The opposite is -1/2. Example 2a deals with a trapezoid and the slopes of perpendicular lines, as well as parallel. The height of a trapezoid is the length of the segment that is perpendicular to both bases. In trapezoid ARTP, line segment RT and line segment AP are bases. Can line segment EZ be used to measure the height of the trapezoid and explain? Well, here we have EZ, and RT and AP are the bases. For EZ to be able to be used for the height of the trapezoid, or at least to measure it, it needs to be perpendicular to both bases. So we have a couple things we need to find here. We need to calculate both the slope of RT and the slope of EZ. Remember, for lines to be perpendicular, their slopes need to be opposite reciprocals. Well, if we pull off points R and T, R is at -5, -3, and T is at -1, +1. We're going to use our slope formula M equals y2 minus y1 over x2 minus x1, and we'll go 1 minus the -3 over -1 minus the -5. This simplifies into 1 minus -3 is a +4. -1 minus -5 is also a +4. So the slope of RT is simply 1. Now we need to do the same thing for EZ to see if we have opposite reciprocals. We're once again going to use our slope formula y2 minus y1 over x2 minus x1. So we'll have -8 minus a -1 over -2 minus the -3. This simplifies into -8 minus -1 is -7 over -2 minus -3 is 1. So this is -7. Well, can EZ be used to measure the height of the trapezoid? It would need to be a perpendicular slope, which means these two slopes would need to be opposite reciprocals, and they are not. So our answer is no. And let's use the definition here to help us with our explanation. The slopes of segment RT and segment EZ are not opposite reciprocals and are not perpendicular. In part B, are the bases parallel? For this question, I need to compare the slope of RT with the slope of AP. Well, the good news is I already know the slope of RT from our previous part. Our slope's equal to 1. Now we need to check the slope of AP to see if it's also 1, since lines that have the same slope are parallel. So we can pool the points for AP, -4, -10, and 6, 0, and use our slope formula. Slope equals y2 minus y1 over x2 minus x1. We'll end up with 0 minus -10 over 6 minus -4. This simplifies into 10 over 10, which is equal to 1 for our slope. So the slope of RT is 1. The slope of AP is 1. They're the same. So are the bases parallel? Yes. We can once again use our definition in our explanation. The slopes of RT and AP are the same. So the bases are parallel. In our next example, the graph shows the diagonals of a rectangle. Determine whether JL is perpendicular to KM. And with perpendicular, we're looking for opposite reciprocal slopes. So we can once again look at the slopes of JL and KM. With j at 2, 6 and L at 6, 1, we can use our slope formula to calculate 1 minus 6 over 6 minus 2. The slope of JL turns out to be negative 5/4. Now for Km. K is at 6, 6, M is at 2, 1, and we can once again use the slope formula to calculate 1 minus 6 over 2 minus 6. This turns out to be negative 5 over negative 4, which is the slope of negative divided by a negative is a positive 5/4. For lines to be perpendicular, they need to have opposite reciprocal slopes. While negative 5/4 and 5/4 are opposites, they are not reciprocal, so our answer here is no. Segment JL is not perpendicular to segment KM since the slopes are not opposite reciprocals. In example 3, we're given a graph. Determine whether the graphs of 3x plus y equals 12, y equals 1/3 x plus 2, and 2x minus 6y equals negative 5 are parallel or perpendicular, and explain. And we could probably do this without the graph itself, but we'll do it with the graph and algebraically. So if we look at our first equation, 3x plus y equals 12, let's get this into slope-intercept form. Let's move the 3x to the other side of the equation here by subtracting 3x from both sides. We get y equals a negative 3x plus 12. If we look at the second equation, we have y equals 1/3 x plus 2. And with the third equation, the 2x minus 6y equals negative 5. Let's work to get that into slope-intercept form as well. First step, subtract 2x from both sides. We have negative 6y equals negative 2x minus 5. Then divide everything by negative 6. We're left with y equals negative 2 divided by negative 6 is just a 1/3 x. And then negative 5 divided by negative 6, might as well call that a positive 5/6. Now, if we were just to do this alone, we can look at the slopes. Here we have a slope of negative 3. So our slope here is negative 3. Here we have 1/3, so our slope is 1/3. And here we also have a slope of 1/3. Well, just comparing the slopes, I would say this 1/3 and this 1/3, these two lines are parallel because they have the same slope. Then when we look at the negative 3, well, negative 3 is the opposite reciprocal of 1/3, so this graph is going to be perpendicular to these two. We can say y equals 1/3 x plus 2 is parallel to 2x minus 6y equals negative 5 since they have equal slopes. And as we graph the y equals 1/3 x plus 2, we have a y-intercept of 2, up 1 over 3, up 1 over 3. Of course, we could also go down 1 and over 3, and then down 1 and over 3 again. And if we carefully draw this line in, we can do the same thing with our 2x minus 6y equals negative 5. That has a y-intercept here of 5, 6, so just below the 1. And we could go with the slope up 1 and over 3. It leaves us here, and up 1 over 3 here again. Same thing with going down 1 and over 3, and down 1 and over 3, which leaves us a line just like so. So not only can we see that the slopes are 1/3 in just algebraically, we can then also look at the lines themselves and go, yep, they're parallel. Now what about the other line? We can write that 3x plus y equals 12 is perpendicular to both since its slope is an opposite reciprocal. When we go to graph this, we can graph our y-intercept here at 12, and had to extend the graph a little bit. And then a slope of negative 3 means down 3 and over 1, down 3 over 1, down 3 over 1, down 3 and over 1. And sure enough, when I draw this graph in, hopefully you can see where we have the right angles created there with the two other lines. So it's one thing to be able to say, all right, look, these slopes are the same, so they're parallel, but also remember that's what it actually means on the graph. Or to say, wow, the slopes are opposite reciprocals, so they must be perpendicular, but that's what it looks like on the graph as well. In example 4a, we're going to find a perpendicular line through a given point. So write an equation in slope-intercept form for the line that passes through 4, -1 and is perpendicular to the graph of 7x minus 2y equals 3. So the first step is we need to find the slope of the 7x minus 2y equals 3, but it's not in slope-intercept form, so it's not easy to identify the slope quite yet. So let's start off with the line. 7x minus 2y equals 3, and get this into slope-intercept form by getting that y alone. We'll subtract the 7x from both sides, and we're left with negative 2y equals negative 7x plus 3. Then divide everything by negative 2, and we're going to be left with y equals negative 7 over negative 2. Just keep it 7 halves, since a negative divided by a negative is positive, so 7 halves x, and then 3 divided by the negative 2 is going to leave us negative 3 halves. So here's our equation of this line now, y equals 7 halves x minus 3 halves. So what is the slope? The slope of this line is 7 halves. So the slope of the perpendicular line is the opposite reciprocal of 7 halves. Well, the opposite reciprocal there, you have 2/7 being the reciprocal, and negative 2/7 is going to make it the opposite reciprocal. So find the equation of the perpendicular line now. Just like when we were finding parallel lines, now we have our slope being m equals negative 2/7, and our point that we're going to use from our question, and we'll start off in point slope form. So y minus the negative 1 is going to equal negative 2/7 times x minus 4. Simplify, we have y plus 1 equals, distribute now, negative 2/7 times x is negative 2/7 x, and then negative 2/7 times a negative 4 is going to be a positive 8/7. Now we need to get this into slope-intercept form, so we need to move this 1 on over. So let's subtract 1 from both sides, and subtracting 1 is the same thing as 7/7, which leaves us with the equation. I'm going to go ahead and write it on over here so we have some space. Y equals negative 2/7 x plus 1/7. And that is my solution. We have the opposite reciprocal slope, and we're good to go. So as we go to solve one last example, write an equation in slope-intercept form for the line that passes through negative 3, negative 2, and is perpendicular to the graph of x plus 4y equals 12. So we need to get this into slope-intercept form first, so x plus 4y equals 12. Get that y alone, so subtract x from both sides first. We're left with 4y equals negative x plus 12. Divide everything by 4. And what this leaves us with is y equals negative 1/4, as that's a negative 1x, so negative 1/4 x plus 3. So the slope of this line is negative 1/4. So the slope of the perpendicular line is the opposite of negative 1/4, which is simply 4. So find the equation of the perpendicular line. We'll start off with our slope of m equals 4, and the point from the question, -3, -2, and point slope form, which is y minus y1 equals m times the quantity x minus x1, and make our substitutions in. Y minus the -2 is going to equal the 4 times x minus -3. We're left with y plus 2, if we simplify, equals 4 times x plus 3. Now we can distribute. Y plus 2 equals 4x plus 12. And now finish by subtracting this 2 on both sides to get the y alone. So our final answer here, y equals 4x plus 10. A lot of steps to follow, but if you are organized in showing your work, and remember the rules that parallel lines have the same slope and perpendicular lines have the slopes that are opposite reciprocals, you'll do just great. So as we summarize this lesson, two vertical lines are parallel if they have the same slope, and so you have parallel lines, same slope, and perpendicular lines, or two non-vertical lines, are perpendicular if the product of their slopes is -1, which is a fancy way of saying opposite reciprocals. And what do we mean by products of their slopes being -1? Well, take the slope 3/4. The opposite reciprocal of that is -4/3. When you multiply this through, you get -12/12, which is just -1. That's it for this lesson on parallel and perpendicular lines. Good luck.